So today we're having just a quick guide to meta-analysis, okay? So like you do the complicated part of a meta-analysis is the systematic review part. I'm not going to teach that to you today. So essentially, let's just talk real quick about what a meta-analysis is. It takes all the Cohen's D's and measures the variability from your studies and it converts them and it aggregates them into a average Cohen's D. So and it has like a confidence interval as well. So the main result you're going to get is an average Cohen's D with an effect size. So what you'll notice here is that this is where our meta-analysis starts. You'll see it in our data file. I'll have it labeled a little bit better by then, but you'll see it at the end of our stats package. Right now, it's in its own spot because I had this one that existed already. Now, essentially, all you do is first, I'll take you here in a second, but what you need to do is you need to enter your Cohen's D's and your variability of your Cohen's D's and the IDs of your studies. That's just the author's name. You can literally just write the author's name and year. I had a little extra in there, but it doesn't really matter. And then you just change these values to match. And you click run. I'm going to make sure that I get that thing to quit popping up. But that's that guy right there. But you hit run. Perfect. And what you end up with, you get this output, and the only thing I really want you to focus on is this model result that has your estimate of your Cohen's D, your standard error of your Cohen's D, your Z value of your Cohen's D, your P value of the Cohen's D, and your upper and lower limit of the Cohen's D. That's all you need. So it's this, lower limit, upper limit. These are the important things to interpret. The p-values and z's are there if you want them, but these are the only three numbers I'll need from you on your homework. Okay? And then, so with this case, you see that your Cohen's D is 0.67, which is a good size effect, and our 95% confidence interval is from a small effect to a massive effect. So we know we have an effect that's greater than 0, but we don't know if it's actually a meaningful effect. We got to get more studies to have a better estimate, just like everything else with our confidence intervals. But essentially, we can see it's significant if we wanted to say that, but significance isn't always the only thing. In terms of a Cohen's D estimate, we're not trying to figure out if it's significant. We're trying to figure out what the actual effect size is. And in this case, it's about 0.7, but it could be as low as 0.12 or as high as 1.2. And we know that means we have a crappy interval of estimation. And so we need to run more studies, find more studies. Essentially, that's all that we can do. So what you need to run a meta-analysis, if you look at the inputs, is you need Cohen's D's and you need variability estimates. Well, where do you get these from? Well, the first place that you go is you go to, you go to this webpage. Yep. Oh no, I failed. I was uploading that. Let me go back. Come on, be there. Be there, buddy. Come on, buddy. Fail. Okay. We're all good. All right, so I'm going to we're right here, and what you'll see is that you'll have to take data from other studies, and you're going to have to put the information you have into the calculator. So let's say you had means and standard deviations. You insert your means, your standard deviations, and your ends. And let's just say I can make some up here, right? 5, 10, 2, 5, 20, 70. Hit calculate, right? And in this case, we can see that this Cohen's D is negative 1.1. and it has a 95% confidence interval from negative 1.6 to negative 0.58. And that's for the Cohen's d, and it has a v-score of 0.0711. It's this number and this number that you have to put into the R document. So I'm just kind of pointing it out, like, okay, this is how you convert from means and standard deviations to a Cohen's d and the Cohen's d variability, so that we can run the meta-analysis. If you have your t-test results, all you need are your sample sizes. Let's say we had 10 and 10 and our t-value is 7, right? What's our, see, like from that, we can get our Cohen's d. If we have equal sample sizes, you can make it a little bit easier, but I generally do recommend just using the unequal sample size groups. If you have a main effect that you're pulling out from another group, right? So from a factorial ANOVA, you're like, oh, I had 10 in group 1, I had 20 in group 2, and my F-stat was 3. What's my Cohen's d? Well, my Cohen's d is 0.6, my variability is 0.15, and it goes from a negative Cohen's d to a positive Cohen's d, so we know that that one wouldn't have been significant necessarily, but you know, we put that into our data file. So this is all we're doing right here, is getting our d's and our v's. That's all we're doing. So t-test unequal sample size. If we just have the t-test p-value, we can input this as well. So you can see that right here. If you just have the p-values, and from that you can calculate Cohen's d. Means and standard errors. So instead of means and standard deviations, means and standard errors, you can do that as well. If you have frequency tables, so like you can literally just put in, oh, I had, you know, it's for a lot of different tests you can do this. So this is like the frequency of people who said yes, the frequency of people who said no. And then, oh, we're like, okay, 30 said yes, but 5 said no. 55 said yes, and 85 said no. We click calculate, right? And then we get our D and our V, and you should just use this first column. Don't worry about it. They're just, they're just giving you these numbers. The stuff down, if you have a chi-squared, you can convert that to a Cohen's d, which I didn't teach y'all chi-squared. I think they didn't in the lab either. I think they cut that. So unstandardized regression coefficient, but those are B's. Standardized regression coefficients are betas. I just talked completely about betas, not B's, but ultimately that's what you will, if you see something that's like the predicted, the coefficients in a multiple regression model are greater than 1, or they're labeled as B's, not betas, then you just enter those in here. So, oh, my beta was 7. My standard deviation of my dependent variable was 5. My treatment was 8. My control was 9. I click calculate. It can't do it for some reason, which is kind of funny to me. Oh, this is standardized regression coefficient. So these are actually your betas. My bad. Hit calculate, and then it can do it for you. But you also have unstandardized regression coefficients where it's 7. Standard deviation is 6. Treatment size is 4 and 2. Calculate what's my Cohen's d, my V. Basically, we got to get these numbers, and then once we get those numbers, we put them in here. We put our Cohen's d's here, and we put our variabilities here. You put the study name here, and then you hit run. That's all you have to do to get your meta-analysis. And guess what your homework is? I want you to get on PsycInfo. I want you to find 4 articles on the same topic. They don't have to be perfectly the same measured, but what you want to do is you want to be able to examine the average effect size for the conceptual effect. So, for example, if it was me, I'm going to look at the effect of race on medical treatment decisions. I'm looking for 4 papers Ideally, I'm looking for t-tests because I know that's what I want to see, but I'm just looking for 4 papers that have these effects, and I want to just do a little mini meta-analysis with these 4 papers just to prove to me I can do this. And how am I going to do that? Well, for my homework, you're going to attach your papers to your homework. You're going to get your Cohen's D's from the calculator. And you're just gonna and you're gonna get your V's from your calculator. And you're gonna run it. You're gonna get a meta-analysis. And when you get that meta-analysis, what do you get here, right? Well, this picture tells the whole story. It doesn't give you the exact numbers, but you know that your effect size. Well, actually, it does give you the exact numbers. You can ignore that. Ignore the console output. Your Cohen's D is 0.67. Your 95% confidence interval is 0.13 to 1.22. We know our P is greater than 0.05 because 0 is not included. But we can also say, we don't really know if this is a super small effect or a massive effect. We need to get more studies. We don't really know yet. But I want you to do this. I want you to run this. Go ahead, screenshot this, and give me your interpretation of this picture. And you've just run your first meta-analysis. And what I'm pointing out is that a meta-analysis is not that hard thanks to programs like R and thanks to that calculator that you can get at the top of your specific of our specific stats program, that online calculator that converts effect sizes into Cohen's D's and V's. Okay, so I want you to run a simple meta-analysis on 4 studies that you can run a meta-analysis on. And when can you run a meta-analysis? When the concept of the independent variable is the same across the different studies, and the concept of the dependent variable is the same across different studies. You don't have multiple independent variables, you just have one. So mine would be race on pain treatment. And those measures of race can be completely different. It can be different groups, different racial groups, I don't care. But as long as I'm comparing 2, right? And then my dependent variable can be pain treatment measured in all the different ways we measure pain treatment. But they don't have to be the same across the study. They just have to conceptually be the same. So I know I've given a really quick overview of meta-analysis, but it's not that hard. What are we doing? We're averaging the Cohen's D's across a specific 2-group comparison. And we just have to make sure that our independent variable concepts match and our dependent variable concepts match. And what's great about this is that, it's a good way, if you want to do a meta-analysis and you want to get a good way to get published without necessarily having to go through the IRB or anything horrible like that, this is a good way to do archival research to find, does the field actually have an effect? Now, what you're doing today is just finding 4 studies. What you would really do is find all the studies ever published on race and pain and do that meta-analysis if you were me. But ultimately, this is just a practice. I want you to find 4 studies on the same question. I want you to extract the 4 statistics. If you're struggling with one paper, cut it. Find another paper that has the same independent variable construct and the same dependent variable construct, and run your meta-analysis. It is not too hard. And you will see this in our stats program as well.